Okay, so let's take a look at the table for JSON file and its extension. Uh, so in this example, I'm gonna go over JSON file. So far, for the data file, you've been using the text file that includes CSV file and TSV file. Okay, so comma separate value and tab separate value, or sometimes you use the separate as a white space. But also there is a JSON file that is to share data file with the other organization. Okay. Before I mentioned that there was an XML file, uh, you know, like 15 years ago, XML file was the popular file type to share the data through different organization. Okay. But Google felt like it's not that convenient, so Google made a new file format called the JSON, and it has a similar syntax with the HTML. Okay, definitely XML also has a similar syntax, but JSON, it kind of reduces some syntax from XML and HTML. So if you just look at it, you can tell how easy it is to share the data. Okay. So many applications use JSON file format that include social applications such as Twitter. And Twitter provided the API for uh, the customer like you or users to download their file or access their file to analyze the social behavior of the community using the keywords. Okay. So anyhow, JSON has been popular nowadays, and the, as we have seen, social media is the mostly include. I mean, the many people are talking about certain topic using social media such as Meta and Twitter, even LinkedIn. LinkedIn is for mostly for professional, but still they share their own the opinion with the emotion. So so it's very interesting to analyze the Twitter data for sentiment. Also, it means that you should use a JSON the library to parse when you read a JSON file from Twitter. Okay. So if you look at the simple example of a JSON file, mm, you know, it is always enclosed with the curly bracket. So you can see left and right curly bracket. And then it has multiple elements such as name, age, and car that you can define by yourself. And each element has value, like a name as a John, and both, you can enclose them with a double quotation or a single quotation. And age element has value 30, and you can tell this is integer because there's no single quotation or double quotation used. And car value is empty. In that case, you can put null. Okay? So very straightforward. You have the curly bracket with the element key and element value. So element name and value, element name and value. Yeah. So very, very simple example. So in the lab for sentiment analysis, uh, I actually shared the movie data, like a movie Minion. Uh, that was like around the, uh, was it like 8 years ago, 6 years ago? I forgot. But anyhow, movie Minion first came out in Hollywood, and then I collaborated with Twitter to collect the 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 tweets for about the movie Minion. Okay? So if you look at, I mean, if you download the Minion tweets taro.zz file, taro and zz are to compress your file, and also even that you can maintain the structure of the folder, right? So you can untaro it, uncompress it using taro-zxvf command. So once you download this taro.zz file using the shell commands tar -gxvf, you can extract the folder name and the files that is uh, that exists under this directory. Okay, so you can see uh, 5 the files. Uh, um, the also I mistakenly named the file as a CSV file, but actually this is JSON file. So the file format, it sounds like a comma separate value, but if you open it, you can see the JSON file format. So that is my mistake, but still you can take it as a JSON file. It's not a CSV file. Okay, that's what you need to remember. So the first, once you uploaded that JSON file on the, for example, Twitch staging directory by following the lab, you can create the table such as raw Twitch table that is to read the JSON file line by line. So, initially you can just take the JSON file as a string. So you have only one column named like a JSON response. So this is just column name. And since it has a complicated structure, at least like this, you have like multiple lines of this kind of data. So you just take it as a string. Yeah. So the first thing is you just need to read the data. So your table row Twitch has one column JSON response string like this. As a human, there are multiple elements, right? But just take this as a one column. So you have a one column with that read the entire value without looking at its structure. That is the first thing you have to do. So it is stored as a text file because this is, no matter what it is, JSON, CSV, TSV, they are all text file. And the location is on the Twitch staging directory. Okay, so this is just to simply read the JSON file. So if you query the records from the first table that's just you created, then you can see, very complicated like a JSON file structure, and this is actually one column. Okay, even though as a human you can see many elements, but we just simply to read this file. So you can see only one column named the JSON response that includes the entire record. Yeah. Does it make sense at this moment? Any question? Okay. Okay. Now you actually need to use a get JSON object function that is to parse the JSON data. Okay. So this is very important function that you have to use to parse the element of the string that you just read. Okay. So as a human, you can just look at the string and you can find out the element, but since this is a computer, you need to you need to tell the computer, this is the element 1, that is the element 2, etc. Okay? For that, you have to use a get JSON object function that is given by Hive. Yeah? So before that, we also need to look at the structure of a JSON again. The JSON file start with the root object, and they can be referred to by character like a $ character. Okay? So there is a root object that is basically not shown, but you can tell that is the root object whenever you start from the root. And for each root or from each object, you can go to the child object. Then you need to use dot notation to look at the child, because mostly JSON has the tree structure. Okay? So to go to the child from the parent node, you need to use that notation. And also in array, there is there's an array like element, then you can use square bracket. And also to represent any like element of array, you can use star as a wildcard. So this is basic syntax that you can use. And then let's take a look at the example, because if you just look at the definition, it's not hard to understand what it is. But if you look at the real example, then it could be much easier. Suppose that we have the JSON file, and this is a single record of the JSON the file, and then the single record is enclosed within curly bracket. So this is single record. It's like a single row of the table. Okay. So for single row or single record equivalent value, you have a store element. Also, you have email element and owner element. And email owner, the value is very simple. Value is separated by colon and owner name Amy string with a double quotation. Email within the double quotation as well with the email. And each element is separated by comma. Okay. But store is more complicated because it has a sub element. Okay. So store, the element store has a sub element, and sub element has fruit and bicycle as a sub element as well. So store has two like element. It's like product of the store. And first product element is fruit. Second is bicycle. And for example, bicycle, you can specify its value as with a sub element again, with the price key, price element and color element. So this bicycle, you have one bicycle, its price is $19.95, and its color is red. Okay. But for fruit, you could have a list of fruit, and then you can put it as a like array that starts with the backslash. Okay. And then each fruit, you have a weight, like 8-pound type is apple. And second fruit is weight 9-pound, type is pear. Okay? So this is how you can, represent the element in JSON format. So, even though you don't know, you never have heard about JSON, you can simply say, oh, this is just one way to represent data. Okay? And XML and HTML, they have a similar structure, but they use more complicated, the 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 syntax. Here you can just use curly bracket, but in XML and HTML, you need to put more complicated like a word, like a start, and etc. But instead of that word, you can just use left curly bracket, right curly bracket. Okay. So even though you don't clearly understand the XML, it's okay, because we are not learning XML. We just want to read the XML element using getJSON object function. Okay. So there are many complicated structure for JSON, but who cares? We just read the element using getJSON object function. Okay, so to read it, same as we tested, you can use select statement. So suppose that you create a source JSON table that is to read the entire JSON file as a string. So this source JSON table has a single column. This is a single column table. Okay, and this single column includes the entire the record as a string, and then like this, your single row table, the column has entire value as a string. Yeah. So if you have one record, this is actually single string that can be stored into a one column as a value. Okay? So you need to actually parse it using getJsonObject function. So if you call getJsonObject function, you need to call the table name. The table name is source JSON, and then column name is JSON. So you can call source JSON.json. Okay? You can simply call JSON because you already mentioned that the table name is source JSON. But if you want, you can also call repeat calling the table name that column name JSON. Because you have only one column JSON, again, you don't need to even put the name of a table because table name is already mentioned here. And then now the second parameter should be the syntax to drill down and find out the element. So for example, if you remember, there is a $sign, there is the root, and then root.owner element. Okay. If you look at here, root is somewhere because this is the element. So root is somewhere here. And if you call root.owner, then you have to, using the root, you can go to one of the element name owner. So root.owner, if you want to read the root.owner from source JSON file, you can read the Amy. But again, it is possible because you call getJsonObject function. Okay. Similarly, you can use selection element to test it. If you call getJsonObject function again from source JSON table, source JSON table has only JSON column, so you can call JSON or source JSON.json, and then it starts with the root.store and then .fruit of backslash first element 0. So if you look at here, it says root.store, right? Root.store. So you are here, and then you call the fruit root.store.fruit and fruit element 0. So first element. So root.store.fruit and then backslash square of 0. The first element is this from this array. Right? You have array element 1, array element, first element, first array element, and second array element that is indexed by 0 and 1, right? So root.store.fruit of 0 means, weight or type. Okay? So it returns the curly bracket with the weight 8 and type apple. Okay? So very easy. You just use a getJsonObject and you can drill down from the root to element and sub-element, etc. using that notation. Okay? And so, for some reason, if you try to call root dot any element that doesn't exist, then it return null. Okay? So after root, you should call the element name that exists. Okay? So this is the first time that you have seen JSON and getJsonObject function. So I'm sure you have any question here. Anyone have any question? Oh, there is a syntax to call the array. So array, start with a backslash. Any other question? No question? Okay. So let's take a look at our a leg example that you need to complete sooner and later. So you initially have a row twitch table that has only one column to take each record as a string, even though it has a complicated JSON structure. Now you can a second table that extract each element from the first table. So you can create table named the Twitch text. This time you can specify the element that you can extract from JSON table. I mean from first table. So that is the ID of a tweet and created at date. The when this tweet was created, that is created at. And from here you can also generate like a created a date, year, month, date, time, but all these 5 columns are actually from created at element. And then you have a text that is the content of a tweet. And you have a time zone that specify from where this tweet was generated. Okay? So let's see how we can extract value from first table to here. So the you have a Twitch text. I mean, you need to insert the data into Twitch text. That is the second table. To second table, you need to insert the data from row Twitch. Okay, so if you look at the next line, you have a select statement, and from is actually added in front, not at the end. You can do both, but you can also put from over select in the beginning. Yeah, so simply you select values from the column, and you select, you query the column from row Twitch table, and then the result is inserted into second table named the Twitch text. That's what we are doing. But to do it, you need to call getJSON object function. Okay. Do you guys have any question at this moment? Even though this is very complicated code, the big picture is you are inserting the data into Twitch text table that you just created, right? And it has like a eight columns, right? And then the data you read from row Twitch table. That is the first table that read the entire JSON file as a single. This is like a single column table because each record, even though the structure is complicated, this is simply the single string. Okay. Now let's look at the easiest the parsing first. Okay. So if you look at here, let me see. Okay. If you look at here, there is the last column should be time zone. If you look at here, the last column is time zone column, right? So you can read the time zone value from row Twitch table using getJSON object function, and then you have to call the column that exists in row Twitch table, because again, the first table, row Twitch, you have only one column named JSON response. Let me show you the first column, first table again. Okay. So this is your first table, row Twitch table, and it has only one column JSON response. Okay. So, okay, I want to read the JSON response column, especially using getJSON object. When I read the JSON response column, I want to look at root.user. I want to look at user and user's time zone. Okay, root.user.time zone. So if I look at the data, so this is the data from the first table, right? Row Twitch.json response. This is your first table and column name. So there's a root, and you need to find out user. So you have to look at all element, then somewhere, yeah, you can find out user here. So root to the user dot, and there's a sub element. If you look at it, there is a location. That should be location. Oh, sorry, the time zone. Time zone. Okay. It's hard to find out. Let me quick check. That was time zone, right? Yeah, user dot time zone. So root somewhere dot user dot. Let's see if you can find that time zone here. Oh, right here, time zone. Okay. So, oh, I want to read the root dot user dot time zone, and value is null. Value is empty. Okay? Because the tweet user normally hide their location to generate the tweet. Yeah, because of a privacy issue, you don't want to expose your country or time zone. So like more than 80% of tweet doesn't include the time zone, and it doesn't say anything about the address or location. Okay, it's okay. Yeah, but our point is, oh, we can find out element that match it to time zone column. So, time zone column, the first record's time zone column becomes empty. Cool, but the point is we can find it, right? Let's look at the next last, the second last, the object, I mean the element that is root to the text. So this is tweet text column. Yeah. Oh, root to the text. Let's look at it. So if you look at root to the text, if you look at here, there is a root, and you can find out text somewhere. Yeah, here you can immediately find the text element, and its value is some weird URL. Yeah, so this guy tweets the URL as a tweet text. So the second last column's text column value becomes some URL string. So that is the value for this column. Okay, okay, this is easy, right? And then let's look at another easy example. Let's look at the first column. Yeah, this is the first column. Let's look at the second column first. This is a lot easier. If you look at the second column, that is to read, you definitely need to call getJSON object function, and then equals to root dot created at element. Okay. Oh, very easy. Where is it created at? So if you look at the data, there's a root and created at. You can immediately find. Oh, its value is the date and time the tweet was created. Okay. Oh, that's easy. So I can find the second columns. The second column's name is actually created at. So using created at, you can assign the value. That's based on this getJSON object function. Okay. Also, let's look at the first column's value. First column is to call cast function to convert the result into the big integer data type. So, even though it looks complicated, it is simply to, by using cast function, the result of the getJSON object becomes big integer data type. Okay, so it is very simple function call. Okay, so if you look at it, it is looking for root.id string. So this is tweet ID, but it is in the format of a string. So you want to convert it to big integer instead of a string. Okay. So let's look at the data. If you look at the data, there's an ID. Oh, sorry, ID string here. Okay. So root2.id string, that is the string value to point at a tweet ID. but you want to convert it to big integer. That's why you want to cast it. So you get the value of first column. That is ID. And then, okay, so far you know the value for ID and created at and value for text and time zone. Okay. Now let's look at created at date and others. Okay, so created at needs the 3 lines of code. So let's look at the first column. For first column, that is to read the value using substring. So it is saying from root.created at date. So you have a created date. You want to read it from 27th characters from this long created at date string. From 27th string, you want to read only 4 characters. So simply, this is actually year of created at. So if you look at the first column, this is year column. That is the year to create this tweet. And if you look at the created ad is very complicated, long, like a date and time, right? So if you count from 1 for each character in the string, at 27th, you can see 2015. And if you read the 4 characters after that, it is 2015. Yeah, you substring this string from 27th location, and you read only 4 characters. That is 2015. Okay? Actually, year. Yeah? So for first column, you query. This is first column. This is first column. You read the created at, and then you substring. You call substring to read from 27th characters for 4 characters. This is very simple, but anyone who lost, can you guys follow me? Yes. Yeah, you want to find out 27th character from this string. 4 characters, including 27th, like a character. That is the definition of a substring, right? Substring starts with the parameter as a string, and then you have a second and third parameter. Second parameter locate the string that you want to take out, right? And then how many characters you want to take out? That is 4 characters. Okay. Now, okay, so since you know the first column clearly well, you can easily read this fourth, fifth, and six, 7. 6 and 7 are much easier because you want to read from 9th character for 2. So this could be the day. And from 12th character, you want to read the 8 characters. So this could be time. Yeah. So what I'm saying is from 9th to 2, if you look at the created at element, from created at, if you count from 1, 2, 3, 4, 5, 6, 7, and 9, 9 is for 2. And then if you read the 2 characters, it is day, right? So 24. And also if you want to read from 12, 9, 10, 11, 12, from 12, if you want to read the 8 characters, that is the time. Like a 05, like a 5:50 a.m., 50 second. Yeah. So if you come here, there's a day column and time column. They can be read from these two getJSON object and substring like a query. Using these two functions, you can read the day and time. Yeah. I started them first because they are easier than other column. So far, so good. Any question? You know, it's very easy, but if you lose somewhere, then it becomes nightmare. Okay? So you have to let me know if you are lost. Yes? You mean here, right? Yeah, because this line belongs to concatenation. So this one looks like three line, but this is actually single line, like the logic, single line expression that I'm going to explain soon. So let's see. So, okay, let's go to the other column. So you know first column, second column, right? And third column is using concatenation. And there are three parameters. So the first parameter is substring. And second one is white space character. Third one is substring, but this is, you already know, this is year, right? Because next column is called year. That is exactly the same. So you can say, oh, this is year string. Before year, you can concatenate white space. And then the first one, the first substring is to read the definitely created at and then from 1 to 10. So from first character and then remaining 10 characters should be the first substring. Okay? So that is actually for the third column, date. So if you look at the data set here, you read it from 1 to 10, from 1 for 10 characters. So there is a Monday, August 24, right? These are total 10 characters. And then you append, you concatenate white space, and then you append the year, 2015. So it is date that says Monday space, August space 24 space 2015. That becomes the value for the other column. So this is one expression to concatenate three string together. So that becomes date. Does it make sense? Do you know what, I mean, do you see how you can create the value for third column? Again, feel free to let me know if you are lost, because this is very easy, but if you are lost, it's really hard to, figure out what it is. Okay. All good? Sure. Okay, so now you know first column, second column, third column, fourth column, and even 6, 7, 8, 9 columns. Now there is a fourth column, right? First, second, third, fourth, fifth column. Fifth column is to find out the month. Right? If you look at here, first, second, third, fourth, fifth. Fifth is to find out month from created at. And if you look at the data, yeah, here is the month that starts from fourth character with the 3 characters, right? It starts at the location of 4, and you have 3 characters. Like August is like a AUZ, April is like a APR, January is like a JAN. Okay? So, okay, so I need to read only 3 characters. Okay, so if you look at here, from the 5th location, you read only 3 characters. And then, so you can take out any like 3 characters for January, February, March, and April. But this time you have a case case close, like a case condition. So if the result of this is, for example, January, Jan equals to when Jan, it meets the condition of when the result of this expression is January, Jan, then I want to return 0, 1. Okay. And if equals December, if this substring becomes December, I mean, if this substring expression returns December DEC, it check each condition and then it meets here. Oh, it's DS December, so I want to return 12. Okay. And you close case with end. So it starts with the case and it closes at end. So this is like a case close or case expression. Yeah. So it's very simple. I mean, it looks very complicated, but if you understand it clearly, it is very simple, like a, the code. So does it make sense? So you start with one single lines of record that looks like this. So you have only one column, row twist. JSON response. And then each record is one single string. However, if you use getJSON object, you can parse each record's element to find out, to extract element's value and assign that element's value into the column that you defined. Okay, so you can find out ID elements, created elements, and text elements, and time zones element. And you can even find out date, year, month, date, time from created element. Yeah, so that's what this insert override table and select statement is for. Okay, so you have a second table that is to parsing the JSON structure. This is all possible because the HiveQL support getJSON object function to parse JSON data type. And then, as I said, most of the social media data, you can share it as a JSON file format. So using this approach, you can read each element's value. And now you can analyze your data using this table. From the first table, there is no structure. So you cannot find out, you cannot analyze this data because this is simply a string. You cannot analyze string value because this string has a structure. So you need to parse it. And then you create new table that read each element's value as a column. So now this table is what you've been using, right? Once you have the table that has some structure like this, now you can run HiveQL code to analyze it, right? Okay, so yes, this is what I said, there are multiple example to find out each element from getJSON object using getJSON object from row to each table. So this is what I just have explained. Okay. Now let's move on alias. You already get used to alias, but let's take a look at it again. So for example, if you want to the alias a function called result. For example, there is a movie rating table, and you read this column user ID, but you want to calculate entire user ID records using count function, and then you can alias it with count. If you want, you can insert as like an alias. Same for the table name. You can create table with a table name, and when you create table, you can also insert the data after query the data from somewhere. And you can put as, or even though you don't put as, it's okay. The result of a select lemma should be the value for this table the users created. Okay. Okay. And also, uh, the if you have a multiple table and if you wanna join them, there is no join here, but even using comma, you can represent them as a join without putting join as an operator. So you can join these three tables, but when you do that, since you need to call the condition to find out the equal column, um, for table 1, you can simply alias it as a T1, table 2, alias it as T2, etc. And then you can call it like a T1.id column equals T2.id column, and T2.id column equals T3.id column. Okay. So this is how you can use alias. Okay. Again, you can insert AS, or you can omit it. It works well, no matter what you do. Any question? So this is what you've been using. Um, yeah. So okay. And as I said, for sentiment analysis, you need a dictionary table. So it should have you could have a multiple columns, like a dictionary. The word type, word length, and word itself, and word, the word syntax, and stem, and polarity. But most important column that are useful for this dictionary table is word itself and its polarity. Yeah. So if you have a word named abandoned, it's negative, right? And if you have abandonment, its polarity is negative. Yeah. So you could have a sentiment dictionary that you can use for sentiment analysis. And the dictionary table for sentiment should have a complicated columns, but most important column is the word itself and its polarity. Okay? If you have love, what's the polarity for love? Positive. And if you have a word hate, what's the polarity? Negative. Yeah, these are the most important column that you can use as a dictionary. Um, so when you read the tweets, you can use it. Also, there is a retro view syntax that you also need to know. Retro view is to retro view has a syntax like you have a user-defined table generated function, and then you could uh, add the multiple alias. So, for example, if you have a table like if your table has a two column, like column 1 has column name is page ID and the add ID list, and value is contact page, and the contact page may have a list of the ID. Okay. In this case, if you want to explode the array, you can do it. You can explode this array using explode function, right? So you can make element 3 and 4 as a 3 and 4 as records. But all the issue is I also want to maintain this column's name with each element. Then you have to use retro view. Okay? So for example, if this table name is page as, you can read the page ID and the add ID, but the add ID is from the explode the explode function. Okay? So the from the when you call the add ID list, so when you explode the add ID list column, you can alias it as a add ID table. Okay? And then the result of this is also can be add ID. Okay? So if you use this retro view, your page ID here can be represented with the add ID that is like a table name, table record name. I mean column of the table record. So simply, you can call the page ID as a column that you want to keep, and then you can call alias column name that is exploded from add ID list array. Okay? So again, if you just simply explode this column, you can do it, but you can only show the element as a record. But if you use a retro view, then the each element is regarded as the table record, like add ID, and they can be a part of record that comes with the page ID column. So retro view is important to keep the column together with the column that you are exploding. Okay. Does it make sense? You see what I mean? Okay. So exploding is just to explode the array elements, right? But there is no way to keep another column's name. But using retro view, you can keep another column's name that comes with the array element. Okay. So this is a very important function that you can use. It is because if you have a tweet ID, if you have a tweet that has a value RT, campus, Aonde, Mora, OS, if you just explode it, you can only see each word. However, for each word, you should also represent each word. What is the tweet ID that included this word? Okay. So you have to use a retro view to explore the words, and then that word is retro viewed, so it can be listed with the original tweet ID using retro view. Okay. The reason we need this the ID, I mean the reason you need to keep this ID is if you find out the polarity of each word, like suppose that all the words in your paragraph, if you calculate each word's polarity, and later on if you summarize all polarity, then the result should be collected with the ID again. I mean, if you have I love you as a paragraph that belongs to tweet ID 1, you can explode all the word to find out each word's polarity. After then, if you find out each word's polarity, you need to combine all these words again with your tweet ID 1. Okay? So now your tweet ID 1 has a list of words and each word's polarity. Okay. Also, yeah. So, the to do it, actually, you can create the view like a L1 view and L2 view and L3 view. View is like table. Yeah, table and view. Actually, it is working like same. Only difference is for table, where's your data for table? Do you remember where is the data for table? Exactly. Your table data is located in HDFS as a physical file, right? But for view, uh, data is not located in HDFS. That is in memory. Yeah, so it's like a temporary table. Yeah, so view is exactly the same as table, the way it works. Only difference is, the physical location is not in HDFS, but in memory. So you know, if you call the view, then um, the you can keep the data in the memory, not in the HDFS. So you lose the data if memory is full for view, or you can see the content of view unless you execute the view. Unless you execute the view, there is no data for view. Yeah. Okay, so let's see. Maybe it's time for me to explain the Aaron L12 review. Okay. So let's think about this. I have a tweet ID one, and it has value I love you. Let me just simply make it as a all lowercase letters. So this is one tweet record. So there is a tweet ID one, and its content is tweet text I love you. Okay? I need to explode it using lateral view to say the tweet ID one should have a word I, and tweet ID one has word love, and tweet ID one has word you. Okay? So this is how I need to explode. The reason I explode this value is because I want to look at the dictionary to find out the polarity of this. Okay? So I need to explode it. I need to explode this sentence using sentence function and explode function. Okay? So now I have also using lateral view, I keep the tweet ID one. So I have these three records now. And if you look at the dictionary for each word, you can find out the sentiment, the polarity. What do you think? Is it neutral or positive or negative? Neutral, right? So, it's neutral. And how about love? Is it positive or negative or neutral? Positive, right? Positive. And how about you? If you look at the dictionary, neutral, right? So, now I can find each word's polarity by looking at the dictionary. It is possible because I, explode it, and also I call the lateral view to keep the tweet ID. Okay? So if you look at the error view, that is basically to explode. So error view is actually to create this. Okay. Let me just insert it again. Error view is to make this. So this is L1. So this is L1 view. In L2 view, um, Oh, sorry. L1 is just to L1 explore sentences and we create list of words. Okay, sorry. So this is actually L2. L1 is to create the explode of a sentence. So this one is like L1 sub element I comma dot comma U. So here the U exploded, so it becomes one comes with the element like this. So in L1 syntax, you read the text column, and then for each sentence, if your paragraph is composed of 3 sentences, all 3 sentences comes with the ID, tweet ID, like one and one sentence. If you have one more sentence for this, you have another one and the another list of words. But we have only I love you, so the result of L1 is with the tweet ID and list of the word as a sentence. But L2, you keep the ID and you list each word. I love you. And yeah, so this is what how to read the L2 value. And for L3, you find out each word's polarity. That could be negative and positive. And then if there is a negative, you return -1. If positive, return 1. Neutron, there is 0. So actually it's negative. Neutron, then it is 0. If it is positive, it is +1. And if it's neutron, there is also 0. That is what L3 view is doing. Okay. So you have actually 3 view, L1, L2, L3, to read each element from the tweet ID text. Okay. And the reason we use L3 is because okay, so again, this is case, you can use case syntax for it, okay, that you have seen. Like if polarity is negative, return -1, positive, return +1. Otherwise, we can return 0, and it's aliased as a result is aliased as a polarity. Okay. And L3 is important to calculate the entire sentence. Like if you look at this code, you create table named twist sentiment, and you can store it as anything else, but this time I just want to show you, you can store the file type as a ORC file. That is a more complex data file format. But most important thing is select statement. If you look at the select statement here, you read the data from L3 and you want to group by tweet ID. Okay? And then for the polarity column, you need to sum them up. And if entire sum is greater than 0, it means that this paragraph is positive. If entire sum is less than 0, it becomes negative paragraph. Okay? So what I mean is, from L3, using tweet ID, there is 1 here, right? If you sum entire polarity 0, 1, 0, what's the result of sum of 0, 1, 0? 1, right? Is it positive or negative? Positive, right? So, I look at each word's polarity, and then if I group them by ID, tweet ID, and then if I sum entire word's polarity, and if there is greater than 0, it's positive paragraph. Yeah. So, oh, this is positive. So now the table tweet sentiment has tweet ID 1 and its sentiment as a positive. Okay. So now this column, this table, tweet sentiment. Now this is a table because you want to keep it in your HDFS. The tweet ID is 1 and its value is positive because because sum of the polarity for these three grouped by tweet ID should be greater than 1. Greater than 0. So it's positive. Yeah. So simply, as a human, you can immediately, as a human, once you see these lines of table, tweet ID 1 and I love you, you can calculate, neutron, positive neutron is like a 0, 1, 0 plus 1 plus 0. So it's positive. You can tell it as a smart human, right? But for HiveQL, you need to use multiple views and table to calculate entire word's polarity. And even, for L3, you have to look at the dictionary to find out the polarity. What's the polarity of I? Neutron. So you return 0. Love, in dictionary, you can find out its polarity as a positive, so you return 1. U as a neutron, 0. Okay? And then you group them all by the tweet ID, and then you sum all the polarity, like a 0 plus 1 plus 0, and greater than 0, so it's positive. So very complicated process for HiveQL, but basically, as a human, you can immediately calculate the sentiment from entire word, right? So that's why there is a L1, L2, L3 view, and finally there's a tweet sentiment table that keep the paragraphs, the polarity. That's the process what you are doing in the lab for sentiment analysis that you're gonna see soon. Does it make sense? If you have another example, like for example, if I have the tweet ID 2 that says I hate you, then to simply, as a human, if we simplify the process that we have seen, then it is simply what is the polarity for I? 0, right? As a neutron. And what's the polarity of heat? -1 as a negative, right? And what's the polarity of U? 0. So what is the total of this? -1. So total polarity of this paragraph should be -1. That's the negative. So I can tell, oh, this tweet is negative tweet. Okay? So, as a human, you can immediately calculate, right? But you have to follow this L1, L2, L3 process. And finally, tweet sentiment can, calculate it like this. Yeah. So that's what I try to show you. Again, the result of this table value can be stored as ORC data format. This is the compressed file format to save your storage. Okay? So if you open it using your HDFS shell commands, you cannot read it because this is like encoded. Other files that you have seen, you can read it as a human, but to read this, you have to run HiveQL code. but using HTTP shell, you cannot read its code, I mean its data. Okay. And then you have another table, the Twitch BI. This time, you also read the data from Twitch clean and Twitch sentiment to additionally add, to include the entire column from Twitch clean table, and also just to simply change the value positive, neutral, and negative to number 210. So if you look at here, you left out the join between these two tables. And Twitch sentiment has a tweet ID and the polarity. And polarity value is positive, neutral, or negative. But when you join these two tables to generate new table named Twitch BI, you simply include the polarity as a number. Like again, positive is 2, neutral is 1, negative is 0. The reason you change the column value to 210 is to visualize this number using pie chart on the map. Okay? So if you have a number, integer number, that's much easier to create a pie chart. So number 210 are used as a positive, neutral, and negative. Okay? And also there's a regular expression. The previous table that you generated, you can also create new table named Twitch sentiment. That is the final the table. That is to replace the message column when it has a value do you remember what is? Can you tell what is A minus E and capital A minus E and 0 minus 9? Huh? All character? No, actually alphanumeric character. So AZ, capital AZ, 0, 9, 9. So it's like an alphanumeric character. And then what is this cap? Not. So non-alphanumeric character. And what is plus? Say again. Can you make it simple? Yeah, one or multiple times. So any non-alphanumeric character that grew upon one or multiple times, then you want to replace it with an empty string. Empty white space. Simply white space character. So in a message, in a tweet message, if you see non-alphanumeric character, I want to just, it is useless for sentiment analysis. So I just want to replace it as a white character. White space character. Yeah. So this regular expression replace is to filter message column value. Okay? And then it rename it as a column named the message. So also, when you filter it, you make sure tweet ID is not null, and sentiment column has a value 0 or 1 or 2 that you calculated in the previous table. Again, the final table, it has tweet ID column, timestamp column, and message column, but message column should be filtered with only alphanumeric character, and country column and sentiment column that has value 0, 1, 2. Okay? So once you have this final table, you can visualize it. Okay? This is just to show you, how you can replace the non-alphanumeric character to white space. And also, you have used the describe and describe format here table. You can also use describe extended table to show you the extended content of the table. Okay. Yeah. So once you know, once you clearly understand today's lecture, then you can easily complete the sentiment analysis lab after Ngram. Ngram, you easily find out the what's the value, the red cost. I mean, you successfully complete the lab with the Ngram, right? But for today, you have a part one of a sentiment analysis that use the function that I just explained. So I'm sure you can easily complete part one. Okay. So if you look at today's lab, oops. Today's lab is composed of three parts. But before part one, you can easily generate the you can easily generate the table like a twist text that parse the JSON format file as the element, like a 9-column tables named the twist text. Okay? So you need to create two tables today. The first table, raw twist, has the JSON like file format that you cannot analyze, but using second table that you create, you can parse the element of a JSON string with the ID column, created that column with its date, year, month, date, time column, and text column that include the tweet text and time zone column. Yeah? So once you successfully create them, you can show me the result of a second table that include the 9-column value. And then you can download the three files, like a time zone map that you can use for geomap visualization later on. But dictionary.tsv that is to download the dictionary for plurality of the words. And then mostly the movie data, like movie minions data file that you have to uncompress and put into Twitch staging directory. Okay? There are 5 data files, but even though the file extension is CSV, that is JSON file format. Okay, so it should be JSON, but I accidentally put CSV as a file extension, but again, that is JSON. Yeah. So I'm pretty sure you can easily complete today's lab work, but again, assuming you don't have any mistake. So if you have done, show me the result of select statement for the second table that has the value for each column. So we are a little behind because of a technical issue, but I hope you guys can read it by 6 p.m. to show me. Before I go to 5-minute break, any question? Yes. What do you think? What could be? Oh. No. Oh, really? Then you have to remove the files and folders from your home directory in your Linux. How about folders? Did you delete the data folders that you created at Linux? The HDFS has good enough storage, so you don't need to delete the HDFS file. But for Linux, maybe there is a limitation. So you have to remove data file and folders that you created. But don't delete any folder or file that I created. You have to only delete file and folders that you created. Oh, really? Yeah. Let me see. So I guess you guys need to remove. So now, please remove your file and folders in your home directory. You know how to remove them, right? The easiest one is rm-r and your file name and folder name. But you have to be very careful not to delete the existing folder I created. You have to only delete your own file. But let me look at it. Can I remove the file and folder first? That will help other people's to complete their work. That I'm using. Give me a sec. Okay, so so this is the how many storage you guys are using. Anyone is BD9015? The you have a very big file. Can you remove your file and folder that you don't use anymore? Can you share your screen? I'll show you how you can do it. So the can you share it? Your name is Json, okay? Json. Show me your shell terminal. Can you type in go to CD, change directory? So this is what you guys need to do. Okay, please. Oh, sorry. Let me. Okay. So this is the screen of Jingtian, and then again go to the home directory. Connect to your server first. Okay. So from Zoom, you guys need to take a look at to clean your file and folders. Can you make font a little bit bigger? Bigger, bigger. Not smaller, bigger. I want to share it with your classmate, so make it bigger. The font, not the terminal size. Any, can anyone help him to make font bigger? He's using Dell. Mac, so Command plus. So anyone over there just teach him how to make the font bigger? Yeah, just go there and help him. That'll be much faster. Yeah, so please just show him how to do it and it'll become easy. Yeah, like this. Very easy, right? Jingtian, you should know it because this is what you need to know. But anyhow, type in ls minus al. Okay. If you look at here, you never cleaned your folder, right? So other people cannot use their computer. So how do you remove your like data, you think? What's the command? Anyone? rm, right? Type in rm space minus r. And then the most painful one is minion tweets tar.zg, right? You have like a huge number of the space that you are using. So yeah, there is one way, or simply star.gz. Oh, so other people cannot see the screen, so let me share this. How come they cannot see the screen? Let me see. Okay, so let me give you direction again. No, the RM minus. Yeah, you can do it as well. Yeah, hit enter. Okay, and then can you do all of them as well? Type in ls. And then you see many files that you don't use anymore, right? Especially for the blue one. Blue one is the folder. So you have to use rm minus r. rm minus r. And the call like a sensor files, the blue one. And tweets as well. Yeah, hit enter. So can you remove all of them? Okay, so for today, I need to, you know, if you didn't yet, this is what you need to do. Very important to remove your home directory. If not, other people cannot use their computer. So today, when I look at your, I mean, when I give you your mark for today's work, I'm gonna look at your folder as well. So you have to type in ls to show me if your home directory is clean or not. So show me your home directory and your result of B line. Then I can give you credit. You see what I mean, right? So, so Jiangtin, you don't need to share your screen anymore. So stop sharing. And from Zoom, someone said, Paikang, oh, you cannot see the screen, Paikang? How about other people from Zoom? You cannot see, Paikang, you can see it or not? You guys can see the shared screen, right? So Paikang, you have an incorrect option, I guess. So you have to, I mean, other people can see the screen that they share. Who is this? You type in ls to show me the home directory. Park Chan-seo? Yeah, can you please remove all? Type in ls instead of ls minus al. Yeah, if you do ls minus al, there is a useful folder as well. So type in ls. Type in ls. So you need to remove them all. Okay. So Park Chan-seo said, I'm still using it. What do you think? Is it correct? Yeah, yeah. You already put them all into HDFS, right? So why you are concerned? So okay, so remove them all, and then I can give you credit. Just keep check. So part two, you don't need to upload anything, right? Because at part one, you upload all data files into HDFS, right? Yeah, you already upload all into your HDFS. So again, you have to clearly understand what you are doing now. If not, you just run it, but you don't know what you are doing. Yeah. So you have to understand the logic behind what we are talking about. Also, when you are ready, show me. Show me, because we don't have enough time. I'm gonna just stay here to give you a credit. So show me your home directory that is clean. Oh yeah, this is perfect. So who is this? Chan-seo? Yeah, Chan-seo. That's what I want to see. So Chan-seo, you have a clean home directory, right? And then, okay, Chan-seo, people are keep coming, and this is second table, right? Yeah, perfect. And show me your home directory again. I want to make sure. Yeah. PWD. Type in PWD. Okay, Chan-seo, great. So let me give you credit. Um, so give me a sec, Chan-seo. We are at Ch9. Part one, right? So Park Chan-seo in Korean, right? Chan-seo, great work. Feel free to leave.